Assalamualaikum, my name is Muhammad Zikri Hakim with metric number of 172035882 from Group 4, and today our group will be presenting on KIG 2007 project of application of programming. Firstly, let me introduce our team. Our team consists of Muhammad Iqbal Hakim bin Muhammad Robi, Muhammad Zikri Hakim, which is me, Muhammad Najmi bin Muhammad Khairi, and Muhammad Hazi Iqbal bin Adnan acting as our leader.
For the introduction, we choose our title for the assignment to be calculating load on the trailer. For static calculation, the calculation is based on load stress analysis. We ask for the user to input 3 different values, which is x1, x2, and the weight of the load, and based on these 3 values we can calculate many things in the program. So for example, when the user input all 3 values, the value that will be displayed is R1Y, R2 bending moment, shear stress, sigma A, sigma B, and lastly the factor of safety. All of the variables is useful for the calculation, and it's important for the load itself. The compiler that we use during the C++ project is the code blocks. There are many other alternatives that is useful, but we choose code blocks because code blocks is quite user friendly, especially for new programmer, such as for ourselves. That's all for the introduction. Thank you. I will continue with my part in this presentation, which is the algorithm or methodology. I made the flowchart based on the coded program. So for the left side, we can see that for the left side of the flowchart, we can see the main program, and the right side is the chart for all the functions. We have 3 functions: void force, void shear bending, and void von Mises. So for the main program, we start by asking the user to enter x1 value, and then the x1 value is the value between the distance between the front tire and the load. And then next we ask the user to enter the x2 value, which is the distance between the front tire and the rear tire. And lastly, the user is required to enter the weight of the load in kilogram. So that's for methodology. And for each void function, there is no argument. So much like every calculation, there will be, for each void function, they calculate each variable, such as for void force, it calculates the load. Firstly, it calculates the load in Newton, and then it will display R1Y and R2. For void shear bending, it will display bending moment and shear stress. And lastly, the void von Mises, it will display sigma A and sigma B, which will then be used for factor of safety calculation and will later be displayed. So that's all for methodology.
Assalamualaikum. I, Muhammad Zikri Hakim bin Zikara, with metric number of 172035882, will be presenting on calculation. To be more specifically, I will be presenting on manual calculation. For the manual calculations, these are the list of the nomenclature that we will be using. To ease the calculation, a free body diagram are drawn, and the reaction force at the most left of the truck are neglected, as the load is assumed to be most critical at the tire that are connecting the truck to the trailer. Moving on, using the data provided, x1, the distance from the tire to the load, x2, distance from the front tire to the rear tire, letting it to be 1 meter and 4 meter respectively. Also, 10,000 kg for the load weight. We can find the reaction forces by letting the sum of force equal to 0 and the total moment equal to 0. We found that the reaction forces are only in the y directions, which are R2 equal to 32,025 Newton, and using that we can find R1, which is 96,075 Newton. From this, we can now draw the shear force and moment diagram to find the maximum shear stress value at 96,075 Newton and the maximum bending moment, which is also 96,075 Newton at x equal to 1. With that, we can calculate the bending stress with the formula of maximum bending moment times with c, which is just h divided by 2 and divided by the moment of inertia. For the moment of inertia, we can just calculate by using the formula. Thus, by inserting all the value into the formula, we get the bending stress equal to 1.54 megapascal. The principal stresses are equal to the radius plus minus center. For the principal stress 1 is equal to the center plus radius, and with that we got it to be valued at 2.28 megapascal. And for principal stress 2, which is equal to the center minus radius, which we got 0.77 megapascal. With that, we can find the von Mises stress, which we got 2.75 megapascal. And lastly, we can find the factor of safety. Factor of safety is equal to the ultimate strength divided by the von Mises stress. The ultimate strength is 310 megapascal for aluminium 2024 according to the handbook, and with that we got 112.73 for the factor of safety, which is very safe for loading. And that's all for me. Thank you.
In our coding, we use three functions which are shear bending, force, and von Mises. In force function, our program will show the value of R1y and the value of R. In von Mises function, the program calculates the sigma A and sigma B. Then, calculate the factor of safety, then print it to the user. In main function, the program asks the user to enter the x1 value, x2 value, and enter the weight of load value. In shear bending function, the program calculates the bending moment and shear stress by using the data given by the user in the main function. That's all from the program calculation.
Next is the comparison between the manual calculation and the program calculation. So we can see that there are minor difference between both method of calculation, which is at the principal stress and the shear stress, also the factor of safety.
Assalamualaikum and hi everybody. My name is Muhammad Haziq Iqbal bin Adnan. The Mantis number of 17, 20, 49 and 75 will be presenting the discussion on this project. First and foremost, manual calculation is easier when there are a number of assumptions which will cut the time of the calculation. In this case, it assumes that the third principal stress is 0. In addition, a runoff on the weight of trailer is made to reduce the difficulty of calculation, as there are many other parameters need to be computed. Meanwhile, The coded program can execute the calculation without rounding off the weight of trailer due to its capability to store higher floating point in its memory. However, the assumption on the third principal stress is still need to be considered. Next, the manual calculation needs a total of 14 equations to obtain reaction forces, shear stress, bending moment, principal stresses, and the factor of safety for this case. In the meantime, the computer program requires 3 functions and a main function to achieve the same goal as the manual one. The functions are void shear bending, void force, and void one misses. Ultimately, the result is different about 28.1% between the manual and program calculation for the factor of safety because of the presumed considerations. That's all from me. Thank you.
In conclusion, the coded program can be used to calculate multiple variables that we set in the program, but with few exceptions. The first one is the percentage difference between the manual calculation and the coded calculation is there's a slight difference between 28.1%. The difference is due to the rounding off the trailer sweep and the third principal stress assumed to be 0. And the calculation using the program has a few advantages instead of manual calculation, such as by using the program we have higher precision in the final calculation due to higher floating point.